good afternoon. Today is October 5, 2015. We're going to present to you our report, the constant head and falling head permeability test. We're actually group 11 among the group 12. So, the first thing here, I am going to define to you the definition of the permeability. Permeability is a measure of the ease in which water can flow through a soil volume. It is one of the most important geotechnical parameters. However, it is probably the most difficult parameter to determine. In large part, it controls the strength and deformation behavior of soils. It directly affects the following: quantity of water that will flow towards an excavation, design of cutoffs beneath dams on permeable foundations, and design of the clay layer for a landfill linear. Meaning to say, when you say permeability, ito yung paraan or ito yung it is the way how yung liquid passing through. Especially sa soil, dito natin natitest o malalaman natin ang certain area of a soil kung it is well compacted or hindi siya well compacted. So meaning to say, what I mean is, pag sinasabi nating hindi compacted ang certain area or soil, so there's a tendency na magkakaroon tayo ng permeability. Ibig sabihin nun, ibig sabihin nagkakaroon siya ng voids or space. So dumadaloy yung tubig doon sa mga voids na yon or space na yon. So kaya malalaman natin, kaya nga sinasabi dito na it controls the strength and deformation behavior of soils. Ibig sabihin, pag a certain area or soil is not well compacted, so there's a tendency that the building you are going to build on that place or area will deform or magkakaroon siya ng tinatawag na individual settlement. So pag magpapatayo ka ng building sa lugar na kung saan is hindi well compacted ang area, magkakaroon po ng individual settlement or guguho ang naturang building na ipapatayo mo. So kinakailangan ang mga pamamaraan na ito or mga test na ito para malaman mo ang permeable or foundation or permeability. Malalaman mo siya kung gaano ba kalaki ang voids or space ng certain area. So, ang pinaka-affected dito is the quantity of water that will flow towards an excavation. Ibig sabihin, kung nagkakaroon tayo ng constant head and falling head permeability test, so doon natin malalaman kung gaano ba kadami ang tubig na nagpo-flow toward an excavation. When you say excavation, it is an scooping or digging the soil. So you just try to imagine the soil, kung ini-scoop mo yan siya or kinakali mo, binubungkal mo siya sa malaliman. So pag may lalabas na tubig na marami, so ibig sabihin yung area na yun is kailangan yung compacted. Kailangan siyang makompact. Okay. So number 2, design of cutoffs beneath dams on permeable foundations. Ibig sabihin nun, yung halimbawa pag gagawa ka ng dams, so syempre kailangan mo rin siya kung okay ba yung, ibig sabihin nung area ba yun ay talagang okay siya para sa dams. Permeable foundation. So number 3 is design of the clay layer for a landfill linear. Ibig sabihin nun, landfill linear, ibig sabihin nun, yun na nga, yung gumagawa ka ng panglalagyan mo ng mga waste mo, so malalaman mo rin siya. Okay, so the next thing we are going to discuss is the constant head permeability test. We have the procedure first. Mix sufficient water into the sample to prevent segregation of particle sizes during placement into the permeameter. Enough water should be added to allow the mixture to flow freely, forming layers. So means to say, you're going to mix sufficient water into the sample to prevent segregation of particle sizes into placement permeameter. So you have to, enough water should be added. So not too much water, and you have to place or to put a water that is moderately. Okay, so next is remove both the chamber cap and upper chamber from the unit by unscrewing the three nerd cap nuts and lifting them off the tie rods. Okay. So, number 3 procedure is position one porous stone on the inner support ring in the base of the chamber. Number 4, using a scoop or funnel, pour the prepared specimen into the lower chamber using a circular motion to fill the lower chamber to a depth of 1.5 cm. So, ibig sabihin, kailangan hindi siya sosobra ng 1.5 cm ang lalim niya. A uniform layer should be formed. Use an appropriate tamping device to compact the layer of soil to desired density. Repeat the compaction procedure until the sample is within 2 cm or 2 cm of the top of the lower chamber section. So, number 5 procedure is we have replaced the upper chamber section, placing the rubber gasket between the chamber sections. Be careful not to disturb the test specimen. Continue the sample placement operation until the level of compacted material is about 2 cm below the rim of the upper chamber. Carefully level the surface of the specimen and place the upper porous stone on it. So, number 6, place the compression spring on the porous stone, replace the chamber cap and sealing gasket, securing it firmly with the cap nuts. The spring will restrict upward sample movement. Number 7, measure and record the sample length. Of course, you're going to measure. You have your stopwatch and you have your measuring tools, of course. So number 8, assemble the constant head funnel, a rod and meter stick. Use the rod clamp the funnel's lower portion. So number 9, adjust the level of the funnel to allow the constant water level it and to remain a few inches above the top of the specimen. Number 10, connect the flexible tube from the tail of the funnel to the bottom outlet of the permeameter. Keep the valves on top of the permeameter open. Number 11, place a receiver at the top outlet to collect any water that may come out. Number 12, it preferred a piece of tubbing may be connected to the outlet, leading the water to a sink. Number 13, open the bottom outlet valve and allow water to flow into the permeameter. Okay, so number 13, as soon as water begins to flow out, the outlet for a time. So 14, close the bottom outlet valve and disconnect the flexible tubing at the bottom. Connect the constant head funnel to the top side port. So number 14 or 15, open the bottom outlet valve and raise the constant level head funnel to a convenient height to get a reasonable steady flow of water. Then number 16, accurate measure the vertical distance between the funnel overflow level and the chamber outflow level. Then the last is measure and record the length of the specimen. So those are the procedures that we're going to do if we're going to have our constant head permeability test. So the study equipment is being showed to you later. So yun lang po, so yun ang mga pamamaraan po kung paano natin gawin yung constant head permeability. Pero yung mga equipment po, ipapakita ko sa inyo mamaya, may mga equipment po kung paano ba at ano ba yung mga equipment na yun. Ang sinabi ko lang po is yung mga procedure. Okay, so those are the procedure of how we are going to test the constant head permeability. So, hindi pa doon nagtatapos. May mga things pa, there are things that you need to perform the following steps. First, allow adequate time for the flow pattern and or specimen to stabilize. Second, after equilibrium flow has been established, measure the time taken to have the specified volume of water flowing out. Use a measuring cylinder and a stopwatch. Repeat 3 or more times, calculating the average time. So we have the lab. Okay, so we have equation to be used supposedly. So we have equation to be used like this. This is the equation. K is equals to BL over AXT, which is where K is coefficient of permeability, and then B is collected volume of water, then L is length of soil column, then A is area of the soil column, then H is head difference, and T is time required to get the volume. So this is the equation that we're going to use. Okay, so that is the constant head permeability test.
Okay. Falling head permeability test procedure. The following steps are already done. Number 1. Compact the sample in the lower chamber section of the permeameter in layers approximately 1.5 cm deep to within about 2 cm of the lower chamber ring. Use an appropriate tamping device to compact the sample to the desired density. Number 2. Remove the upper section of the chamber tie rods and place the upper porous stone on the specimen, securing the upper section of the chamber with spring to the unit. Number 3. Measure and record the length of the specimen. Number 4. Use the clamp to attach the falling head barrette to the support rod. Position the barrette as high as is possible for practicality. Place the meter stick directly behind the barrette so the height of the water in the barrette above the chamber outflow part may be read. Number 5. Saturate the specimen following the steps outlined above. Number 6. Above the height of the two levels from the outflow level. You need to perform the following steps. After sterile flow has been established, note the drop in head in 2 hours. Calculation. The lab reports shall include the following. Number 1, sample calculation. Number 2, table showing the calculation pertinent to the permeability of the soil. Number 3, average value of permeability. Number 4, calculate the void ratio of oven drying the specimen and taking the dry mass. Equation to be used. Where K is coefficient of permeability, A is area of the barrette, L is length of the soil column, A is the area of the soil column, H sub O is initial height of water, H sub 1 is the final height of water equals to H sub O minus H. T is the time required to get head drop of H. That's all for the equation to be used. And here is Mr. Di Malanas to share some additional knowledge about permeability.
The following application illustrates the importance of permeability in geotechnical design. Permeability influences the rate of settlement of saturated soil under load. The design of earth dams is very much based upon the permeability of the soil used. The stability of slope and retaining structure can be greatly affected by the permeability of the soil involved. Filters made of soil are designed based upon their permeability.
Okay, so thank you very much, Mr. Hamnor Manabilang and Khalid Dimalanas. So that's the importance of permeability. So ngayon po ay ipapakita ko sa inyo ang video ng mga equipment or aparatos na ginamit namin sa laboratory na ito.
Hello, my name is Stephanie Rust, and today I'm going to be introducing the method of performing a constant head permeability test. Today we're going to need a few pieces of equipment to complete this. One thing that we will need is a reservoir connected with some hoses that will have an outlet into the sink, an inlet to a nearby water source, and several outlet availabilities for your permeability testing. We will also be needing some very clean, coarse grain aggregates. We will need a thermometer, a stopwatch, a 250 milliliter graduated cylinder. We will need some wire mesh discs and some porous stones. There is a porous stone in here. And this is a permeameter, which we will also be using. You will need a funnel, a vernier caliper, a regular ruler in inches, and you will also need a coarse grained soil. We're using sand in this case. The first thing that we are going to do is prepare our soil sample within the permeameter. In order to do this, we need to know how much soil to place in the permeameter, but first we are going to ensure that we have a porous stone in the bottom, which you can see that there is, and we're next going to place a wire mesh disc into the bottom. The wire mesh disc simply keeps any soil particles from escaping into the bottom of the permeameter. Before you place the soil in the permeameter, you need to weigh the soil in the source container. Make sure that your scale is tailored. Take the measurement and record. You will then place the soil in the permeameter as required. After you've placed the soil in the permeameter, you will weigh the source container again. Record that weight, and the difference between the two is the weight of soil placed within the permeameter. In order to determine how much soil we are going to need, we are going to use the vernier caliper in order to measure the inner diameter of the permeameter. From this reading, we can see that it is approximately 2.5 inches in diameter. According to the ASTM regulations, the amount of soil needed from the inlet point to the top of your sample is 2 times the inner diameter of your permeameter. So we are going to need 5 inches from this center point up to the top of our sample. In order to place the specimen within the permeameter, I'm going to need another pair of hands, so my assistant Betty is going to aid me by holding the ruler while I place the sand with the funnel. You may have to stop and shake the permeameter a bit to make sure you have it level and you're measuring correctly. And you can see that we have the 5-inch mark from the center of the inlet to the top of the soil sample. The next thing that we're going to do is place a second wire mesh on top of the soil sample, again, to keep any soil from escaping during uplift. From there, we're going to place some of our stone aggregates on top, and this is simply to weigh down the sample. Water can flow freely through this, so as far as the sample is concerned, this is nothing but air. We are simply weighing down the soil so we won't have any uplift effects. The next thing that we are going to do is we are going to hook the sample to the water setup The water source is connected to a faucet. The faucet runs into the reservoir. And the reservoir has an outlet which will enable constant flow, and the outlet as well is available to the permeameters. We're going to need 2 people to perform this, 1 person to monitor the flow of water into the reservoir. And Betty is going to begin and start the sink for us. You also need to unclamp your hose so that water can flow into your system. You're going to want to slow down just a little bit with the water. And we're waiting for equilibrium to be matched. And you will see that the outlet is now going into our catcher. In order to determine that equilibrium has been reached, you will want to observe the water level in the manometer. When this is no longer moving or is at a steady state, you know that equilibrium has been reached. The next step is to measure the difference in total head. This is measured from the difference between the top of the water level in the permeameter and the water level in the manometer. A simple ruler can be used to determine this distance. Once you have determined and recorded the difference in total head, you are going to measure how long it takes to fill 1 graduated cylinder of 250 milliliters with the water. So you will need a stopwatch and your cylinder. When the person places this under, you're going to immediately press start. The water has now reached 250 milliliters. You will record that time and repeat this sequence 3 times. The average will then be taken to use in your calculations. The next step, every time you measure the water timing, is to measure the temperature of the water in the cylinder and to record this as well. There will be a temperature correction within the calculations to take this into account. Once you have successfully completed your measurements 4 times, you have accumulated enough data to perform your calculations. You may now disassemble your equipment and the test is complete.
Okay, so yun yung about sa permeability test. So baka may mga clarification pa kayo para sa mga viewers natin. Di malanas, baka may gusto ka pang itanong, i-clarify sa permeability test.
Kailangan pa ba daan sa permeability test?
Oo naman, siyempre, kailangan natin ang permeability test para matest natin ang daloy ng tubig sa ilalim ng lupa. So, ikaw, Mr. Hamnor, may karagdagan ka pang
Ano bang
tanong?
maaaring magiging scope nito?
Ang method na this test method covers the determination of the coefficient of permeability by constant head method for the laminar flow of water through granular soils. So, yun siya, Mr. Manabilang. So, wala na kayong katanungan.
Okay,
Klaro.
klaro.
Salamat po. So, once again, I am Jelamin P. Saif.
Dimalanas Khalid.
And Manabilang, Hamnor,
We are Group
11. Okay, goodbye.
Thank you.
Hi, exactly, we are here in laboratory to discuss to you the Group 12 seepage analysis report by the United States of the Department of Agriculture, Soil Conservation Service and Engineering Division. The introduction of this study or this analysis are going to I'm going to discuss to you the principles of water flows through the soils are used to determine the seepage quantities, its pressures, and its forces. These are approximate solutions for specific boundary conditions. These are generally limited to a solution to a one value, usually the seepage quantity. The process of determining the boundary of conditions, selecting the permeability values, and making the analysis is a logical approach for evaluating the structures and foundations, performance, and for selecting appropriate control sources or measures rather, to refer to soil mechanics note number 6 for the previous definition. So in this regard, we are going to study how the water flows. We're going to determine which is the seepage quantities, the pressure, and the forces. With the previous lectures or the topics which the group 11 lectured is the permeability. It's talk about the permeability, and by this principles of the water flow, we are going to consider the permeability values. So, as what I have learned in previous reporter, which is the permeability, the coefficient permeability is equals also to the square root of the maximum coefficient permeability multiplied by the minimum coefficient of the permeability. So in this regard, we are actually getting the selecting value of the permeability. So we also have the required site information, which is the chapter 3 of this analysis. By this study, we are going also consider the site information. The site information specifically relating to permeability of materials and seepage flow must collected for each site. So this includes the information for locating boundaries between materials of a different permeability. Generally, the following items are required to evaluate the condition for making a seepage analysis. The first required site information is the topographic maps of the site area, which this first required. Kailangan po nating malaman yung history of the area which we are going to build a building or something establishments, or para masigurado natin kung gaano ka-safe ang ating area. So by this required site, we also have the what we call site area. Then in the letter B, we have the detailed geologic maps and sections of the site that contains correlation of all strata or zone between investigation points. So in this statement, we are also required to know the past studies of the rocks, the layers of the soil, in order to learn about the history of the earth and its life. By this requirement in the number 2, we also have the map should include features such as the reservoir, channels, and other items that may affect the downstream areas and adjacent valleys. Geologic information is to interpreted to indicate uniformities, discontinuities, isotropy, anisotropy, porosity, intervoid permeability, and the mass of permeability, and etc. So by this statement, we are going to consider how our structures are going to build in. But in the letter C, we also have the detailed logs and the descriptions of all materials in the embankments, foundations, and reservoir abutments. The items such as the gradation, the soil structures, the stratification, the continuity of the strata, the bedrock profiles, as terrain pressures, and the moisture content are important. Also, those are the following that are going to consider if we're going to have a site information. Kasi kailangan talaga yan in equating or in what we call that, in build or some constructions that are actually okay, another required site information is the location, the depth, the gradients, and extent of water tables. We have also the directions of the ground flow water, the pressures, the gradients in and from confined layers, which are they will exist after the structure has been constructed. We also have the piezometric levels at the various location and depths, and the geometry of geometry of the structures, and the related upstream and downstream water levels during the planned operations. Okay, with this statement, we are considering the dams here. I will go into cite an example so that we will understand easily. I will actually draw a dam here, then with G. Okay, this is actually a dam. Then we have the part of the dam, the upper stream, the upstream, and the downstream. So what we are going to consider here is, if this is the water surface, we are going to consider here the forces of the water down to the dam. So, this is what we call the total hydrostatic pressure, or also called the F. Whereas this figure, we are actually getting a equation from the soil mechanics, as what my instructor said in Sir Cabanyo, that our total hydrostatic pressure is equals to the W bar H times A, whereas the W is equals to the unit weight of the water, and the bar H is the height from the water surface down to the what we call it, the total hydrostatic pressure. This is the bar H. And our area is considered the we have the what we call the 1 meter strip here. 1 meter strip. We are actually, according to Sir Cabanyo, kailangan ang engineer ay marunong mag-imagine. So therefore, we are going to have this 1 meter strip by use our imagination. So, taking care of that equations, we can use that later in the next chapter of our report. We are actually here the consideration regarding to the seepage analysis. Okay, A. Prepare cross sections showing the boundaries of the structures, entrance and discharge spaces, and the boundaries of the seepage parallel to the direction of the flow. The various zone of the materials in the direction of the structure must be delineated in the relation to the permeability and shown in the cross sections. Each cross section should be represented to determine the relationship and soil conditions, the sand gravel layers, and the upstream and downstream water levels are of the prime importance, should be included. So if this dam are actually considered, we are going also consider the sand gravel layers. Iko-consider rin natin yung layers ng ating mga sand pati gravel. And we will be also have the second considerations in relating the seepage, in checking the water budgets for storage reservoir. Kung gaano kalaki dapat ang gagawin nating reservoir. I don't know how to draw a reservoir, but a reservoir is actually a space or actually a pwede nating imbakaan ng tubig. That is actually a reservoir. Kailangan natin i-consider yan when we're going to relate to a seepage analysis. We will be also have the computed losses, maybe based on heads commensurate with the permanent storage level for the slope stability analysis and checking piping potentials, the seepage pressures and gradients should be determined with the reservoir field at least to the emergency spillway crest. Okay, we have also the letter C. The cross section should be transformed when the previous materials are stratified or anisotrophic. These methods for making transformation are given in soil mechanics. The transform section can be used with either analytic or the graphical methods. Okay, those are three considerations relating to seepage analysis. Okay, for the conclusion, we also have the first, the delineated of the water surface through the upper stream and the downstream. For the second, we also have the reservoir, the checking of the water budgets for the storage of a reservoir. And the third is the cross-section should be transformed the previous section stratified to the isotrophic. Now, those are the consideration when we are going to relate to a seepage analysis. Okay, we also have here the two consideration. The analysis can be limited to the embankments, core and foundations cut off when the embankment shales and foundation soils have a relatively high permeability in comparison to the permeability of the core and the cut off of 100 to 1,000 times greater. Okay? Yan ang i-consider natin. When our analysis daw, kailangan yung embankments natin of the water or the reservoir are getting this range. Sa range na ito, malalaman natin which is the 100 to 1,000 times greater daw yung kailangan nating strata. Ang strata dito na tinutukoy is what is actually zone. Zone is a place where we're going to build our establishment or the dam, or any establishments. Okay? Where the permeable strata expand through or under relatively impervious structures, the seepage analysis is made only on the permeable strata. Okay, the last consideration, we also have the essential to recognize the limitation of the data used. Meron naman tayo tinatawag na limitation use. Kailangan limitation use. Okay. The last consideration in required site information is the essentials to recognize the limitations of data to be used. A high degree of accuracy is needed. Effort should first be spent in refining and collecting data before refined analysis is made. The location of boundaries of seepage flow has marked effect on the result of the analysis. These boundaries are often the most difficult item to define. Okay, in the last consideration, kailangan daw natin limitahan ang ating mga data na gagamitin sapagkat kailangan natin dito ng high degree of accuracy. Yung tama talaga ang ating malikom na datos. And kailangan dito yung effort. Effort in collecting the data. So in collecting the data, kailangan daw natin maghanap, mag-search ng tama at accurate information. Then the third one here is the collecting and data before refined analysis. Before you're going to refined analysis, you're going to collect some data that actually related to your studies or the analysis. Dahil, bakit ito importante in all level or actually the limitation of data? Kailangan because it is how actually magko-conclude ng ating idea para sa ating analysis. The location of boundaries of seepage flow has a marked effect on the result of the analysis. Ibig sabihin, whatever the result, whatever the research we are going to have, mag-e-effect din yun sa ating results of the analysis. Therefore, the boundaries are often the most difficult item to define. Ito daw ang pinakamahirap when we're going to consider is the boundary. Kasi, sa boundary natin or the scope of our analysis, kailangan i-consider natin because that is actually the very important. So, next we have the methods of analysis. Before we are going to have this research or collecting some data, kailangan natin ng methods or yung paraan papaano natin kolektahin yung mga datos na kailangan dito. The methods used most frequently in SCS work are explained in this section. Other methods can be found in the listed references. So, some methods apply only the specific boundary conditions. The all methods can be used to obtain seepage quantities, but may not be the seepage gradients, the pressures, and what we call the forces. Okay, we also have the methods here. The first method we're going to have is the flow net. Okay, the flow net method. The first method we're going to use when we're going to sum or research collecting data in our analysis is what we call including the constructions and use in the seepage analysis given in soil mechanics note number 5. Take note, the soil mechanics here, soil mechanics in note 5. We are considering that study. All the information, okay, in the soil mechanics note 5, this is actually stated that all the information including seepage quantities, the pressure, the gradients, the forces and the velocities can be evaluated. And in addition, in this soil mechanics note number 5, the flow nets can be constructed for any configuration of inlets, outlets, or the flow of boundaries. Or the second method. Okay, before we proceed to the second method, isa lang po ang binabatayan sa flow nets. We're considering the soil mechanics note number 5. Kung saan, yung soil mechanics note number 5 na yan is lahat daw ng impormasyon. Kasali daw sa seepage quantities, the pressures, the gradients, and the forces and the velocities are evaluated. Ibig sabihin, all the data we're going to use here are already evaluated. For analysis we're going to use is what we call the phreatic line for embankments. Okay, by this method of analysis, this method was developed actually in the Casa Grande 2 for embankments. Then, this actually method mainly used for calculating the seepage discharge within a given reach of embankments. It is also used to determine the line of saturation for stability calculations and may be used as a starting point for constructing flow net. Ibig sabihin, before you are going to construct your method, the flow net, kailangan mo munang isagawa itong phreatic line of embankments, which is actually usually made in given reach of an embankment. Then, we also have the third method, the unconfined aquifer, with a vertical or steeply sloping inlet and outlet faces. This method is used on the Deput S3 assumptions. It is an exact solution for determining the discharge for the case shown where the inlet and outlet faces are vertical and the base is impermeable. Few field situation fit the inlet and outlet configuration for a solution. So therefore, those are the methods are actually used in analysis. So we have here an equations. Equations for flow net and properties of equations. We have our K is equals to the square root of the maximum coefficient of permeability. The maximum coefficient of permeability multiplied by the minimum coefficient of permeability. When we're going to solve for the coefficient of the permeability by using the number 2 method, which is the periodic line for an embankment. So in number 3 methods, the unconfined aquifer, ang kinoconsider lang dito is actually the determining of the discharge of the case in figure 7, where our figure 7 is actually here in determining the cross section of dam. By determining the cross section of dam. Okay? In that figure, we are going to have our equations. By that equations, graphical solutions. For the graphical solution, we have here A is equals to the square root of H squared plus a D squared minus the square root of a D squared minus H squared. Okay, that is actually a question of determining A, where A is the rate of discharge. Those are the equation. Where our H squared is the head water plus the number of the equipotential lines minus the square root of the head of the water, the square root of the equipotential lines times what we call our A stands for seepage discharge through the damper foot length. Okay, those are the equations. We also have the graphical solutions of y sub O is equals to the square root of H squared plus D squared minus the D, where our H squared is actually the head of the water plus the equipotential lines minus the discharge gradients. Okay? Those are the formula for using the flow nets properties and equations. That will be. Okay guys, for us to know about the seepage analysis, which is the methods of analysis, here's my companion to show to you some more sample regarding this. Thank you.
Figure 1, flow net properties and equations. The potential for piping can be evaluated for piping-prone soils with free discharge at a horizontal phase flow upward. The largest discharge gradient is compared to the critical allowable gradient for that material. The critical gradient for piping-prone soils is determined by calculating the gradient that will produce a seepage force equal to the buoyant weight of the soil. Critical gradients for low plasticity soils can be calculated by dividing the buoyant unit weight of the soil by the unit weight of water. Normally, natural piping-prone soils will have critical gradients between approximately 0.8 and 1.0. Evidence of piping sand boils has occurred when measured gradients are below the calculated critical gradient. Tests during high water along the levees in the lower Mississippi Valley in 1950 indicated active sand boils were evident where gradients were measured at values between 0.5 and 0.8. This indicates a factor of safety of at least 2 may be needed when evaluating discharge gradients on the basis of calculated critical gradients. Methods for evaluating critical piping conditions have not been developed using the flow net for seepage discharge on natural or embankment slopes. Controlled drainage is generally used to prevent discharge onto slopes consisting of pipe-prone materials. Materials most likely to experience piping include silts or sandy silts of low or no plasticity, silty fine sands, silty clay of low, and most poorly graded fine sands. Seepage pressures may be determined at any point by deducting the head loss accrued to that point from the net head across the structure. Uniform distribution of pressure is assumed between equipotential lines. Average seepage velocities can be determined by dividing the seepage discharge within a flow channel by the area of the flow channel, distance between flow lines times a unit length of structure. The total seepage is equally divided between all flow channels. Letter B. Special cases. Methods had been developed for special boundary conditions whereby the seepage rate, Q, or quantity can be determined. Estimates of pressures and gradients can also be in some cases. Letter B. Spatial cases. Methods had been developed for spatial boundary conditions whereby the seepage rate Q or quantity Q can be determined. Estimates of pressures and gradients can also be made in some cases. So in this matter, the spatial cases is developed, and the rate of the equations we will be using it later. Number 1, the phreatic line for an embankment. This method was developed by Casagrande for embankments located on relatively impervious foundations. The procedure involves locating the line of saturation, phreatic line, through an embankment when full seepage equilibrium has developed. Seepage rate Q can be calculated from certain points on the phreatic line. This method can be applied to embankments with various zoning patterns and drainage conditions as depicted in figures 2, 3, 4, and 5. It can also be applied to the transformed sections as depicted in figure 6. Definitions of terms, assumptions, and methods of solutions are indicated in the figures. Seepage through the embankment above the base can be determined by this method. To be applicable, the slope angles of the embankment and zone should be within the limits indicated in the figures. The method can be used on 4 sections of zone earth fills and on transform section provided the ratio of D over H is greater than unity. This method is used mainly for calculating the seepage discharge within a given reach of an embankment. It is also used to determine the line of saturation or stability calculation and may be used as a starting point for construction of flow net. The construction of transform sections is also covered in Soil Mechanics Note 5. It should be noted that whenever the seepage discharge is calculated for a transform section, the coefficient of permeability to be used.
Hello guys! Ngayon, papakita ko sa inyo kung paano ba kukunin or malalaman kung ang isang dam ay safe by using continuous blanket and aquifer. Ngayon, meron tayong isang figure. Sa figure na to, merong H stands for net head to this. Z stands for thickness of natural aquifer. D stands for thickness of aquifer. Y stands for submerged unit weight of blanket. And L1 effective length of upstream natural blanket. L2 embankment, length of embankment. L3 is effective length of downstream natural blanket. Ngayon, nalaman natin kung ano na mga pangalan niya. Ngayon, isusolve natin kung unsafe ba or hindi. Ngayon, ang una natin gagawin, kukunin natin ang L1 tsaka L3. L1 at tsaka L3 ay equals lang. So, isang formula ang gagamitin natin. Ang formula ay L3 equals to L1 is equal to square root of KF over KB times D times Z. Yan. Meron tayong value. Makukuha na natin ang L1 tsaka L3. So, substitute lang. Ngayon, ito. L3 is equals to L1 is equal to square root of KF over KB plus parenthesis times D times Z. Ngayon, substitute natin yung mga value niya. 1 over 0.01001 plus parenthesis times 10 times 12. Then, L1 square root of 12,000 or L1 is equals to 3,046 feet. Ngayon, nakuha na natin ang value nila. Tapos, ang susunod natin kunin is QF. Stands for rate discharge through aquifer with unit length normal section. To section. Ang formula niya ay QF QF is equal to KF times L3. Ito ang formula niya. After niya, substitute na lang natin. Ito, kukuha na natin. Ito ang solution niya. QF is equals to PF times H over length 1 plus length 2 plus length 3 plus length times D. Substitute na lang natin. 1, value na to. 30, value na to. Pinag-add lang natin to is 882 times that. Ang value niya 10. Tapos ang answer is 0.34. I-solve ko na para hindi na maghaba. Okay. CFD. Pag makuha na natin. Ngayon, nilagay na lang natin. So, natin kukunin ay yung HO stand for pressure head under the blanket at downshift 2 to the up down. Ang formula ng HO is equals to height over gantry of yan. Yan ang formula niya. Substitute lang natin. HO is equals to 30 times L3 346 over 882. Then HO is equals to 30, 0.392 or HO is equals to 11.08 feet. Yan, nakuha na natin. Yan ang solution niya. Pagkatapos, okay, nakuha na natin ang HO. Ngayon, susunod naman natin LC. Ang formula ng LC ay LC is equals to Y sub over unit weight of water. Ang unit weight of water in terms of pounds per cubic feet is equals to 62. Ito. Ang formula ng Z. Z Y times Y sub over unit weight of water. Ito. Ito ang value ng Z. Y sub, value nga. Value 55, value ng Y sub. At saka 62 ang constant unit weight of water in terms of pounds cubic perfect. Yun. I-multiply natin. Divide, cancel ang TCF, ang iwan lang is 8. Kaya ang iwan, ang answer is 10.6. Nakuha na natin. So ngayon, kunin naman natin ang FH. Dito natin malalaman kung ang dam ba ay safe if ang answer ng FH ay 1 or less than is unsafe. If 1 greater than 1, safe yung dam. Okay, tingnan natin kung safe ba ito. FH is equals of FC over HO. So, may value natin yung dalawa. Nasolve na natin. Substitute na lang. 10.6 over 11.8. Ang answer is 0.89 meter. Unsafe. 0.89 meter is less than 1. So, ang dam natin ay unsafe. Okay?
Okay, hanggang dito na lang nagtatapos ang aming report, Group 11 and 12.
And we are hoping that we get some ideas and knowledge regarding our report.
Thank you sa panunood at sana masayahan kayo.
And before this video end, let me express our heartfelt thanks to Nor A. Munabila as a video editor and Kamat Carmela as our assistant personnel.
Okay, any question, just email us.
And as a human being, hindi naman tayo we are easily committed mistake. And for those unsatisfied informations and imperfectness, sorry po. And for those thoughts that correct naman, maraming salamat po.
Okay, hanggang dito na lang. Bye-bye!
Thank you for watching!